Greetings everyone. You are welcome in this video tutorial. In this video tutorial, we will talk about queues in C++ and especially queue as an array. Now let us understand what are queues. A queue is a data structure that provides temporary storage of data in such a way that the element stored first will be retrieved first. That is, the element which is stored first is the first one to be moved out of the queue. And this method is called FIFO, first in, first out. To understand it more clearly, let us relate it to some real life examples. You might have seen a queue in real life, queue of vehicles waiting at the petrol pump, or queue of people waiting at the bus stop for the bus, etc. So like I have given here an example of people waiting at the bus stop for the bus, and this is a queue of people. You can see the person who enters first in the queue. This is the person who enters first in the queue. Then the next person joins, then the next, and so on. So the person who enters first in the queue is the one to move out of the queue and board the bus first. So and he will be followed by the next person and then the next person. And the person who joins last in the queue will be the last person to leave the queue. So this is the principle behind the queue, and this principle is called FIFO, first in, first out. The one who joins the queue first is the first one to be removed from the queue. Now let us understand the operations on queue. A queue is a linear data structure. It is controlled by two operations, insertion and deletion. Insertion operation takes place from the rear end of the queue and deletion operation takes place from the front end of the queue. If you look at the example here, this is a queue in which 5 people are there. Now this is the front of the queue, which is the beginning of the queue, and this is the end of the queue, and it is also called the rear end of the queue. All the insertion operations that takes place from the rear end of the queue, and the deletion operations takes place from the front end of the queue. And insertion operation adds an element to the queue. So whenever a new element, suppose the sixth person wants to join the queue, so he will join from the rear end. And deletion operation removes an element from the queue. So if a person wants to move out of the queue, he will be the person who first joined the queue. So he will be removed from the front of the queue. Now there are two variables, front and rear. Front points to the beginning of the filled queue and takes care of deletion operation. As you can see here, front is pointing to the beginning of the queue and it takes care of the deletion operation, and rear points to the end of the queue. So if this is the end, so this is the rear pointing to the end of the queue and it takes care of the insertion operation. These two operations implement the FIFO method. First in, first out. Now queue can be implemented in two ways, as an array and as a linked list. Now in this video we will talk about queue as an array. Array implementation of queue uses an array to store data, an integer type variable usually called front which points to the beginning of the array, and an integer type variable rear which points to the end of the filled array. So if we take an example here, if we suppose this is an array which has 5 elements 0 to 4. So if this array represents a queue, then in this case the front points to the beginning of the queue and rear points to the end of the queue, and end of the queue is the last element which is filled in the queue. So it contains the index number of the last filled element of the queue, and front contains the index number of the first filled element of the queue. So if we have to denote this in C++, so we will write int q5, where int is the data type, the type of data which we are going to store in queue. Q is the name of the queue, you can give any name to it, and 5 is the size of the queue. And then to represent front and rear, we will define two variables of integer type, and according to this scenario, we'll look at this scenario here, front is 0 and rear is 2, because you can see here 3 elements and the front is 0 and rear is 2. Now let us understand the insertion operation more closely. Initially, when the queue is empty, front and rear can have any integer value other than any valid index number of the array. So you know the index number of the array start from 0. So you can give front and rear any invalid index number, like you can initialize them by any negative number. Here we have initialized them by value -1. You can see here front is -1 and rear is also equal to -1. Now when the first element is added to the empty queue, it goes to the 0th position of the array. And in this case, both front and rear are initialized to value 0. It is very important to note that when there is only one element in the queue, then both front and rear are same. And they are both pointing to that element only. So when the first element is added to the queue, both front and rear will be changed and they will be initialized by the value 0. After this, every insertion operation increases the rear by 1 and inserts new data at that particular position. So after inserting the very first element, suppose we have inserted 10 here. When we inserted 10 in the beginning, both front and rear, they will be pointing to 10. They will contain the index number 0. But when the next element 20 is added, front will remain the same. There will be no change in front. Only rear will be changed. It will be incremented by 1 and 20 will be added here. And similar is the case of 30. As arrays are fixed in length, elements cannot be inserted beyond the maximum size of the array. There is a maximum size of the array. We cannot insert elements beyond the maximum size of the array. And if we try to push data beyond the maximum size of the array, it results in data overflow. Now let us diagrammatically explain this insertion operation again so that it becomes more clear. Now let us consider this as an empty queue in which there are 4 elements 0, 1, 2, 3. This is queue as an array with index number 0 to 3. In the beginning, both front and rear, they are initialized by value -1 because there is no element in the queue. So when front is -1, rear is -1, this indicates that my queue is empty. Now suppose I want to insert 10. Now inserting 10 will make front equal to 0 as well as rear equal to 0 because this is my first element. So this element goes to the index number, it will have index number 0 and both you can see both front and rear, they are pointing to this element. They are containing the index number 0. Now after adding the first element, when we add the next element, suppose I want to insert 20 now. So when I insert 20, I will increment rear by 1 and front will remain the same. You can see front is 0 but rear is incremented by 1 and rear becomes 1. So this is the position of my queue. I have 2 elements, 10 at 0 and 20 at index number 1. Front is pointing to 0 and rear is pointing to element number 1. Now in the next step, suppose I want to insert one more element, 30. So if we insert 30, again rear will be incremented by 1. And again front will remain the same. So front is still pointing to 0 and rear will have value 2. Initially it had value 1. So this will be incremented by 1 and now it has value 2. Now if we take one more insertion operation, then suppose I want to insert 40. Again rear will be incremented. Initially rear was 2. Now rear will become 3 and 40 is inserted at this position and front still remains the same. Now you can see the queue is full. And if I try to insert one more element, suppose 50, it will result in overflow because my queue is full. Now let us talk about deletion operation. The delete operation deletes the very first element from the queue. We cannot insert any element from the queue. Only the first element can be deleted from the queue. Any attempt to delete an element from the empty queue when front and rear both are -1 will result in data underflow condition because if the queue is empty, it is not possible to delete an element from the queue. Each time the deletion operation is performed, the front variable is decremented by 1, incremented by 1. So whenever we have whenever the deletion operation takes place, front is always incremented by 1. This should be incremented. When there is only one element in the queue, that is when front is equal to rear, deletion operation of that element makes the queue empty and both front and rear will be assigned the value -1. So we have already discussed also, when there is only one element in the queue, both front and rear, they will point to that element only, and in that case, when that element is deleted, front and rear both will become -1 as the queue becomes empty. Now let us explain the deletion operation pictorially. Suppose this was my queue earlier while inserting. I inserted 4 elements in the queue and my queue was full. Front is 0, you can see here, front is 0 and rear is 3. Now suppose I want to delete an element. So deletion can take place only from the beginning of the queue, from the front of the queue. So I simply increment front by 1. My front will become 1 and rear will remain unchanged. You can see here rear is 3. Now suppose this is my position of the queue after deleting one element. Now suppose I want to delete one more element further. So in that case, now this is my front of the queue. So this element will be deleted from the queue. So when I delete this element, front will simply be incremented by 1 and front will become 2. You can see here front will become 2 and rear will remain same. Rear is pointing to index number 3. Now deletion of one more element. Now the front is 2 and it contains the value 30. So if I try to delete 30, front will again be incremented by 1. And you can see here after deleting 30, both front and rear, they are pointing to index number 3 and it contains value 40. Now there is only one single element in the queue and both front and rear, they contain the index number of this element. So you can see here again, when front and rear are same, there is only one element in the queue. Now if I further try to delete an element from the queue, this element will be deleted from the queue and both front and rear will become -1 as the queue becomes empty after the deletion of this element. And if I try to further delete an element from this queue, it will result in data overflow. Now main points to remember, let us discuss again. Queue is empty when front is -1 and rear is -1, and deletion from an empty queue results in queue underflow or data underflow. Queue has only one element when front is equal to rear, and except the case when front and rear are -1. Except this case, whenever front is equal to rear, queue has only one element. Queue is full when rear is equal to max -1, where max is the maximum length of the queue. And insertion in the queue which is full results in queue overflow. Addition of element causes rear to be incremented by 1 and front remains unchanged. Very important to note, whenever we add an element, rear is incremented by 1 and front remains unchanged, and deletion of an element causes front to be incremented by 1 and rear remains unchanged. So whenever we delete an element from the queue, front is incremented by 1 and rear remains unchanged. So let us see the program to illustrate the operations on the queue as an integer array. So I have given it in different colors so that you can easily identify all the functions. So again we have included 2 header files. This is the size 4 size of the queue. Now this is the class queue in which I am declaring an integer array data which is of size 4 and then 2 integer type variables front and rear which will point to the beginning and end of the queue. Now in the public section, I am declaring a constructor which is initializing both front and rear by -1. Now there are 2 major operations, insertion, insert and deletion. So we'll discuss void queue insert. If rear is equal to, we'll check if rear is equal to size -1, it means the queue is full and we cannot insert more elements to it. Else if rear it is not equal to size -1, we will check if rear is equal to -1. We will simply say rear plus plus and front plus plus, because if rear is -1, it means the queue is empty and the element which we are going to insert is the very first element. So in that case, both front and rear, they will be incremented and they will become 0. Otherwise, if it is not -1, rear is simply incremented by 1 and we enter the data and the data is stored in the array. Now let us look at the deletion operation. Now while deleting, we will check whether front is -1 or not, because if front is -1, we will say queue is empty, or we can say queue underflow, and we will return, because it is not possible to delete an element from an empty queue. Otherwise, we will display the data which is present in the front of the queue, data front, and then we will check if front and rear are same. If front is equal to rear, it means there is only one element in the queue, and deletion of that element causes both front and rear equal to -1. You can see here front is -1 and rear is -1. And if there is not only a single element in the queue, more than one element are there in the queue, in that case front is simply incremented by 1. Then we have given a display operation also. In this we are displaying the queue from front to rear. We will simply take the control variable I and initialize it by the value of front, and we will go till rear, and we will keep on displaying all the data one by one. We'll simply start from front, increment it by 1 every time, and do this operation till it is less than equal to rear. Now in the main, I will create an object of queue, and this is a temporary variable. We'll use a do while loop so that it will run again and again. We will display the menu, 1 to insert, 2 to delete, and then 3 to display, and 4 to quit. And we will input the choice. If the choice, according to the choice, we will check. If the choice is 1, we will call the insert operation. If the choice is 2, we will call the deletion operation. And the choice is 3, we will call the display operation. So unless or until the choice is 1, 2, and 3, the loop will continue, and if it is not equal to 3, it will exit. Now let us understand the sample run of this program. So when I will run this program, this menu will be first displayed, and I will be asked to enter the choice. You can see in the beginning my queue is empty, and front is -1 and rear is -1. So we input choice 1 in the beginning. I need to insert some data, only then I'll be able to perform the other operations. So I will insert item 11, suppose. So if I inserted 11, my front and rear both will become 0, because this is the only element in the queue. So both front and rear will point to this element only. Now again the menu will be displayed, and if I enter the choice 1 again, and I'm entering 12 here, so 12 will be entered here. In this case you can see front will remain the same, and only rear will change, and it will be incremented by 1. Then again the menu will be displayed, and if I enter the choice 1 again, and item value I want to insert is 13, so 13 will be inserted like this. Again you can see front is 0, front will point to this position, and rear is 2, and it will point to this position. So if the menu is displayed again, so if I enter the choice 3, so all these 3 elements will be displayed. 11, 12, and 13 values will be displayed. The values will always be displayed from front till rear. So first it will display 11, and then 12, and then 13. Now the menu will be displayed again, and this time suppose I want to delete an element, so I'll input the choice 2. So it will display only the element which is present in the first position can be deleted. So it will delete the element 11 from the queue, and you can see here now front is incremented by 1, and it will become 1, and rear will remain the same. So rear is 2. Again the menu will be displayed. Suppose I want to delete one more element. So if I want delete one more element, in this case automatically 12 will be deleted, because this is the front of the queue. So 12 will be deleted. So front will be incremented by 1. So front is 2 now, and rear is 2. You can see there is only one single element in the queue, and again front and rear are same when there is only one single element in the queue. So if I input the choice 4, my program will exit. Now again see, let us consider one more program in which I have explained the operations on queue as an array of objects. So in this case, that was a simple integer array, the earlier program. Now I have created a structure containing roll number, name, and total, and I will create an array of this structure. So I am creating a class queue now, and I am creating this array here. This should be stu. This is by mistake, sorry. This should be stu data 4, and I am creating two variables, front and rear. Now in the public section, I will declare a constructor in which I am initializing both front and rear by -1, and then there are two operations, insertion and deletion. Now in the insertion operation, I will again check if rear is equal to size -1. It means my queue is full, and I will return, because I cannot perform insertion operation if my queue is full. Else I will check if rear is -1. It means in the beginning the queue is empty and the element which I am inserting is the very first element. So in this case, I will increment both rear and front. And if this is not the case, I will simply increment rear by 1 and then I will input the data for all the elements of the array. Roll number, name and total. Now for deletion case, I will check if front is -1. I will simply say queue is empty or queue underflow and there is no element to be deleted from the queue. So I will simply return back. Otherwise, if there are elements in the queue, I will simply display the data of the roll number I am only displaying here. In this case, I will display the roll number of the first element in the queue, and then I will check if front is equal to rear. It means there is only one single element in the queue, and deletion of that element will result in both making front and rear equal to -1. And if there are more than one element, in that case front is simply incremented by 1. Now you can see the display operation also. The display operation, again we are starting from front and we will increment I by 1 and we will go till rear and we will display all the elements one by one. Now in the main, I am creating an object of class q and then a temporary variable again, and then again a loop is there. While ch greater than equal to 1 and ch less than equal to 3, I will display the menu 1.insert, 2.delete, 3.display, and inputting the choice. If the case is 1, insertion function is called. If the case is 2, deletion is called, and if the case is 3, display is called. So let us again see how this program will actually run. This is a sample run. So in this case, the menu will be displayed: insert, delete, and display. So in the beginning, the queue is my queue is empty and my front is -1 and rear is -1. So when I input the choice 1, I will enter the data for all the 3 elements of the queue: roll number, name, and total. You can see here. So this data will go to this position. Both front and rear, they will be incremented by 1, and my 0th element data is filled here. You can see here. Now the menu will be displayed again. So if I input the choice 1 again, I will input the data for all the 3 elements, and in this case you can see front will remain 0 and rear will be incremented by 1 and it will become 1, and this data is inserted at index number 1. You can see here. Again the menu will be displayed, and if I input the choice 1 again, I will input the data for the element, and again in this case you can see front will remain 0 and rear will be incremented by 1 and rear will become 2, and this data is inserted at the index number 2. You can see this. The menu will be displayed again, and if I give the choice 3, then it will display the data stored in the queue. As you can see here, all the data from front till rear will be displayed. First 1 Ramesh 235 is displayed, then 2 Shubh 450, and then 3 Raman 432. It is always displayed in this order from front till rear. Again the menu will be displayed, and if I input the choice 2 this time, 2 is the delete operation. So the very first element from the queue, this is the very first element of the queue, so this will be deleted, and for this front will be incremented by 1. So now this is the structure of my queue. Now again I will give the menu will be displayed, and if I input the choice 2, so this is the front of the queue now, this element. So this will be deleted from the queue, and I will have front equal to 2 and rear equal to 2, and only one element is there in the queue now. You can see there, and in this case both front and rear are same. So if I enter choice 4, suppose this is not 1 2 3, so it will be exited from the program. So once again, before ending, let us discuss the applications of queue in computers. A queue is an appropriate data structure on which information is stored and then retrieved in FIFO order, first in, first out. And the applications of queue are as follows. You can see here. Queues find their use in CPU scheduling, printer spooling, message queuing, computer networks, etc. So whenever there is a queue of something, queues are used. In time sharing system, queues help in scheduling of jobs. These are few examples of queue in computers. So this is all for this session. I hope you like this video, and if you like it, please give thumbs up, and you can also subscribe to my YouTube channel. Thank you.